In this lesson, we are going to be looking at adding and subtracting fractions. It's kind of part 2 of this introduction to fractions that we've been looking at. And adding and subtracting fractions, you may want to pause this video, try some things on your own, as well as rewind it and look at it again, because it has a few intricacies that you're going to have to be careful about as you do this. The first thing that makes adding and subtracting fractions easier, it's possible to do it without this if you're incredibly careful, but I find it easier to convert any mixed numbers into improper fractions. And if you forgot how to do that, you can look at the previous lesson on this particular study guide. Just the first lesson, we went over that. So if you look at these examples, so I'm going to kind of skip around a little bit. Again, don't draw these diagrams into your study guide, but it helps me to kind of explain a few things. The mixed numbers that I see here, there are just a few of them. So you'll see this happening here in just a second. These are some mixed numbers, so if I want to convert those into improper fractions, again, it's 3 groups of 9 plus 5 to get your numerator, and 3 groups of 9 is 25, or 27 plus 5 is 32. So that's going to be 32 over 9. Minus, and the numerator for your second one is 2 groups of 9 plus 2, which is 20 over 9. We'll revisit this again later. And here's a few more mixed numbers that I see. These ones here, if you convert them into improper fractions, it's just going to make these problems easier. So we'll leave the 3/4 alone, but we can then convert. And you can see the diagrams here actually show kind of the idea. We're going from 2 and 5/6, and we're going to break those holes into sixths. So we have a total of 17 sixths. As you can see below here, there's 6, 12, and 17 sixths. The next problem, we're going to convert 2 and 1/4 into all quarters, and you can see there's 9 quarters there. And we're going to convert 1 and 3/8 into 11/8. So first thing I suggest doing is, if you see any mixed numbers, to convert them into improper fractions. It'll just make this process easier. The next and probably most important thing regarding adding and subtracting fractions, and you'll see this from the diagrams that we have here in just a second, is to add or subtract fractions, each fraction must have a common denominator. So what you'll notice in this first question that we have here, and then we'll jump into some more difficult ones here. In this first question that we have here, we do not have a common, or we do have a common denominator. So if you look here, 1/5 plus 2/5 is not difficult to do, because here's 1/5, here's 2/5, and that equals 3/5. So the big idea is, if you have a common denominator, you can just add the numerators there. So 1/5 plus 2/5 is equivalent to a total of 3/5. If they don't have a common denominator, what you're going to do is multiply one or both fractions by a constant. So they do have a common denominator. So if you look at this next example, we have 2/3 plus 1/2. Now we can't add those because each piece is a different size. This is thirds and this is halves, which you can't add. So in order to create these into identical or like fractions but having a different denominator, we're going to make them into a common denominator. Now I know I can make 2/3 into sixths if I multiply it by 2. So if I multiply this fraction by 2, what you're going to see is we just converted it into an equivalent 4/6. Okay, so you'll notice here that 2/3 is actually the same as 4/6. I've just divided all the pieces into 2 parts. And why I chose sixth is because the next fraction, which I'll do in red, 2 can become 6 if I divide each part into 3. So what you'll notice here is that that 1/2 can become 3/6. Okay, so now we have a common denominator, and it's very easy now. We can even count them. I can show you right here. We have 1, 2, 3, 4, 5, 6, 7 sixths. So that's equivalent to a total of 7 sixths. Okay, so once you've done that, you've got a common denominator. The rest of this is decently straightforward. All you're going to do is add or subtract. So a common denominator is vital. You're going to add or subtract the numerators. Fourthly, the denominator remains the same. You can see that with the diagrams, with the examples here. If we've got sixths, we're not going to change that. Sixths plus sixths is equal to 6. So the denominator remains the same. And finally, we'll get to this shortly in some examples, is you should reduce your answer to lowest terms if that's possible. So if we look at these next examples here. So let's look at this next one. You might want to write this down in your study guide or try it on your own. The thing I notice is that we don't have a common denominator, but we can make both denominators into 6. So we can leave the first fraction alone, but to convert that second denominator into 6, we have to multiply this fraction by 2. 1 times 2 gives you a numerator of 2. 3 times 2 is a denominator of 6. And now what we can do is we know that 5/6 minus 2/6, if we subtract the numerators, 5 minus 2 is 3/6. And the last thing to do is, if you can reduce it, do reduce it. And we looked at reducing fractions in the previous lesson as well. In this next example, we've already converted our mixed numbers into improper fractions. So 32 over 9 minus 20 over 9 is equivalent to something ninths. And 32 minus 20 is equivalent to 12 ninths. And again, we can reduce this fraction to be 4/3. Okay? So I challenge you to try the next two on your own if you'd like to, but I do have diagrams here. You might want to pause them and try it on your own. I do have diagrams here that are going to help us out. The diagrams are right below. So first thing I did is I made these into improper fractions. I've got 3/4 plus 17/6, but those don't have common denominators. The common denominator here is that quarters and sixths each go into twelfths. So the first thing we're going to want to do is multiply each piece into 3, so that's going to become 9/12, and all of these pieces are going to be multiplied by 2. Right, so essentially what's happening here is we're taking each piece in this and dividing into 2 and making it into 12. So what you're noticing here is that that's going to become 34/12. Okay, lastly, now that we've got a common denominator, we know that we have all these pieces into 12ths. Right, so here's 9/12, here's 34/12. So 9/12 plus 34/12 is 9 plus 34, which happens to be 43/12, which is already in lowest terms. Our last and final example, the first thing I did is converted 2 and 1/4 into 9/4, as you can see here, and 1 3/8 into 11/8, as you can see here. Again, to make this into a common denominator, both of these can become 8ths. So your first fraction, to convert quarters into 8ths, you're going to multiply by 2. So that's 18/8 minus 11/8, and that is going to be, if you're subtracting, still 8ths, but 18 minus 11 is 7.